Hey everyone, this is our lecture 1.1 in Sociology of Deviance, Reintroducing Science. In this lecture, we're really just going to kind of reintroduce science and make sure everyone is absolutely on the same page. Some of you might be science people, some of you might not be. Some of you might have had a really great science education before getting to college, others didn't. So we're just kind of try to get all on the same page in this lecture here. Science is a way of knowing dedicated to understanding the objective nature of the universe. A way of knowing is defined as a method of understanding the physical, social, metaphysical nature of the universe. Science is concerned with studying the physical and social, the things we can actually see with our eyes. Metaphysical things are more like spirits or souls or gods or goddesses. Those aren't things that we study in science, but we study the things we can observe. Science is generally broken into two categories, the natural sciences and the social sciences. Natural sciences include physics, chemistry, and biology. Social sciences include sociology, anthropology, economics, and psychology. So just like the natural sciences, the social scientific research is conducted on multiple levels of analysis. So what we have here is the micro level being the smallest, the macro level being the biggest, and the meso level being in between. Microsociology studies the smallest scale of society or the smallest scale of analysis if you are not a sociologist. In the natural sciences, on the micro level, they could examine the interaction of atoms or the reproduction of bacteria. In sociology, we study on the micro level families and street gangs because the one person connecting to another person is the smallest level we can get in sociology. On the macro level, we look at the biggest scale. These are things like in the natural sciences, we look at orbits of planets, carbon absorption in the atmosphere. In social sciences, we could look at interactions between very large corporations, international peace treaties, those sorts of things. And then on the meso level, in the social sciences, we might look at trade between cities or regions or rivalries between regional sports teams. Those are both on the meso level. They're not quite in the biggest and they're not quite in the smallest. But there are other ways of knowing that are very valuable ways of knowing but aren't science. We have in academia, humanities, and arts. And we do study religion too, but religion is really its own thing. There is the spiritual study of religion, but also to a degree an academic study of religion. Humanities are things like philosophy, history, women's studies, American studies, African American studies, other kinds of studies. Those are disciplines that use a method other than science. And it should be pointed out that many of those other disciplines, I'm thinking right now about things like English literature or women's studies or those things that call themselves studies. They could do some science, but that is not what their discipline is focused on, right? That's what makes the discipline not a science, but a humanity. The arts, things like poetry, literature, those sorts of creative endeavors where there is no one right way to do it, that stuff is pretty easily labeled as arts as opposed to science. Now, we Americans are sometimes bad at understanding science. And you can go to the PowerPoint presentation and use that link right there. And that links to a pretty good article by Nate Silver on why exactly that is. It's not your fault. The American education system simply is underfunded and overly obsessed with testing. So, and I promise you, and some people insist on this, and it's usually true, that your high school teachers did the best they could, and they did a really good job and whatever, and that in a lot of cases is absolutely true. But the way we have our education system set up isn't necessarily to set up Americans to not understand science, but it sets it up so that some Americans understand science, much better than other Americans. So it's really, really inconsistent. That is a structural problem in our society, and part of the reason that motivates me as a teacher is to try to fix that to a certain degree. So, for example, many college students can't really define a hypothesis, which is at the very base of most scientific thinking. To remind you, a hypothesis is an idea about the world which can be disproved when tested against observations. A theory, then, is a testable scientific model about how the universe works. A theory is about as close as scientists get to calling it this is an immovable thing. Scientific theories, it's true, can change, but when they do change, they change very incrementally slow. Hypotheses, on the other hand, can be quickly proven or disproven. So when you say, hey, I have a theory about something, usually in our common language, what you really mean is, hey, I have a hypothesis against something, but that's something you're unlikely to say because, admittedly, it sounds really dorky. So another question surrounding science is, what exactly is science for? Well, science is about understanding the true nature of the universe. It is a way of knowing, a way of understanding the world that can exclude ideology. So if you're doing science right, you should get the same results as someone else who is also doing science right, even if you and that other person have radically different personal philosophies, religions, political philosophies, stuff like that. And science is a way of knowing that is capable of change, right? And that is sometimes, unfortunately, seen as a weakness of science, that things can change over time. But that is what allows us to continue and to progress as a society and technologically, that when something is determined to be untrue, we just don't say, no, it's not untrue, kind of dogmatically. We are open and willing to change if there is reason to do that. So you could ask yourself, what exactly is research? And what is not research? And if you haven't asked yourself that question, it's a good time to ask yourself that question. There is a distinct possibility that you have never actually done scientific research at this point in your education career, and that's okay. We are often, again, this is the laziness of our English language. Other languages don't have as much of this kind of problem. Other languages also have this problem. But when we say research, a lot of times, unfortunately, we mean like Googling stuff or going to the library and reading about stuff. Well, that's learning. It's reading about things. But in the scientific sense, to do research, you are finding out something new that nobody has ever done before. So that could be as simple as counting exactly how many people live in your hometown, right? If nobody's ever counted that, then that would be research. Or even counting the number of trees on a plot of land. Has nobody ever done that? Are you creating new knowledge? Then that is scientific research, even if those things sound super simple. And not research can get incredibly complex. You can write books and books and books reviewing and analyzing other people's work, but if you're not creating new knowledge in that, you're not actually doing what we call research in the sciences. Sorry about that slight pause. You could also ask when doing research, during that question of what is research, well, what exactly is Google doing? Well, Google searches are not research. This is a major area of confusion in our society today. it actually fuels a lot of controversies, especially the phrase, well, you have to do your own research. Well, okay, and that's true. I do want you to be scientific about your ways of thinking, but if you phrase your question in a skewed way into things like Google or whatever, you can do something as easy as, well, you want to know, is red meat bad for you? Just put in, is meat bad for you? And then you automatically get this answer, eating too much red meat could be bad for your health, right? This is a screenshot I got from Google. Well, if I am looking for that information and I want to hear, yes, meat is bad for me, that sentence absolutely tells me meat is bad for me. If I want to hear, no, meat isn't bad for me, I can read that to mean, well, eating too much meat is bad for me, but actually it's not actually bad for me. This flaw in logic is called confirmation bias. This is the tendency to quickly accept information that backs up our ideologies or our preconceptions. This is a super easy research mistake to make. I know very well-respected scientists that have done this, unfortunately. Really what our scientific training does is it causes us to catch our mistakes. Even the best of scientists do stuff like this once in a while. And most, unfortunately, internet users are not actually trained in this way. And this is how a lot of our misconceptions as a society have gotten kind of out of control over the last couple of years. So the scientific method is what makes things science. This is a procedure for acquiring knowledge that emphasizes collecting data through observation and experiment. And if the researcher is not using the scientific method, then they are not doing science. The scientific method maximizes consistency and enhances critical thinking. So we see this laid out on this slide, the steps of the scientific method. There is a literature review. So we look at what are the things that are already said about this topic. Then we develop a hypothesis. Then we identify specifically what are the variables within that hypothesis and determine operational definitions. What does that third and fourth step mean? Well, we make our hypothesis super, super specific is what we're getting at. Then we can collect our data. Then we interpret our results that we've collected. And then if something weird happened or if we find something surprising out, we can repeat those results. And this is the scientific method. Often people have misconceptions about the scientific method, that they are a very rigid set of ideas and how to actually do our science. I want to point out that the whole system, what trained researchers know, veteran researchers know, is that the scientific method is fluid. As long as you do all of the steps and as long as the sense is made of it, then you are still doing science too. It is not a purely linear step 1, step 2, step 3 thing. You might do step 1, step 2, realize you have to go back to step 1, then you do step 3, 4, go back to 2, etc. Okay, that is it for this lecture, and I look forward to having you listen to the next one. See you later.